Hey guys, so this is Module 2. Module 2 is all about chemistry, and you may say, why do we have to learn chemistry? But chemistry is important because, like I told you guys the other day, that we're just big bags of water with some chemicals in it. Technically, we kind of are, and so these are the chemicals we need to talk about. Now, it's not going to be as in depth as we saw with physical science, so it's going to be a little bit uh, different, but a little bit more complex. So a little bit easier, but a little bit more complex. So let's just talk a little bit and get into it. Um, Hebrews 11:3 says, "By faith we understand the universe was created by the word of God, so that what is seen was made out of things that are visible." Okay, that was not the seen was not made of things that were visible. So God made this, set everything into motion. He is in control of all this. R.C. Sproul said, "There are no maverick molecules in the universe." Um, there is not one rebellious molecule out there that God doesn't say that this is mine, my creation. So as we walk through this, kind of keep that in mind, that these things that we seen, uh, so the scene was not made out of things that were visible. So what we see, God just spoke them into action. Okay, so let's keep going. The questions that we're going to ponder in this module, and I like this, how he sets up questions and then answers them. And again, that's why it kind of reads like a book and not necessarily like a textbook. So we're going to deal with three basic things: the composition of matter. This should be a review. We should know that everything is created out of matter. Everything is made out of protons, electrons, and neutrons, and we should know that they combine to be stable into either compounds or molecules, and that these molecules have properties different than the regular elements that they're made out of. And case in point is water. So the properties of water. We did water in physical science a little bit. We're going to talk more about its life properties, um, why it's vital, why it's important, and then we're going to get into the things that make us living and big carbon compounds. Okay, so those are the three basic sections we're going to go through. So hopefully this is not going to, so it's going to be more than three videos, because the carbon compound is going to take probably two or three alone for that to happen. Okay, so let's get on into some review. We've already said that atoms are the basic building blocks of matter. Matter is anything that has mass and takes up space or has volume. We can see here are the three states of matter: solid, liquid, and a gas. And we don't deal with plasma in biology because nobody can live. Life cannot live in the plasma. And we talked about last module that electron microscopes uses electron beams, and you really can't. It could be alive when you're looking at it, but it's not going to be alive for too much, because it's going to burn up, because it's going to be so hot. So we don't really deal with plasma at all, because that's the sun. We're going to talk about the sun being a part of the photosynthesis in that cycle, but other than that, that's about it. Okay, we're not going to get into astronomy, stuff like that. That's not what biology is about. Okay, we talked about, you should remember what an atomic number is, and of course, atomic number, when we look at a periodic table, atomic number is the number that identifies an element. It's the number of protons. Protons are located in the nucleus. Protons are positive, and because elements are electrically neutral, protons and electrons are going to be equal. So magnesium has 12 protons. It also has 12 electrons. Okay, that doesn't mean that is not volatile. Now we know magnesium has two electrons. I think it is in its outer energy level, so it's going to give them up. So we know that metals are very active um, in reactions. So elements are atoms that have, or elements are have all the same atoms, number of protons. So magnesium is an element. Now, atomic mass has to do with the number of protons and neutrons, and usually this is the average of a common isotope, And isotopes are form of the same element uh, with the same number of protons, duh, because it's going to be that element. If you change the number of protons, you're no longer that element, but different the number of neutrons. Okay, so this is when we were talking about half life the other day in class. This is what we mean that they're going to degrade. So how long does it take magnesium 24 to go to magnesium? I think I can't remember if it's 23 or what. Anyway, so that's why it's 24.305. It's an average of all the magnesium isotopes that are out there. So you can just use 24. And again, it is the number of protons and neutrons. Electrons don't weigh hardly anything. And when we're talking about weight, this isn't a whole lot of weight anyway. One atomic mass unit. Okay, and for our intents and purposes, we don't really have to get that much in depth. If we understand magnesium is an element, magnesium makes milk of magnesia, magnesium is an important element in photosynthesis, then it's good. So we're going to get into the ones that you need to know in this section too. Okay, so here's the periodic table. You guys, just basic. This has A's and B's. Most of the time, the newer ones just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyway, goes that way. You see the top number 13. Okay, remember these guys right here. If we put these guys in the bottom up there, then that's where they belong. So periodic table is just really big. We talked about this is group 1. Group 2, we know that these guys, because they're in this family, all have 1 electron. We know that these guys, this side, all have 2 electrons. We know that these guys have 3 electrons in the outer energy, like 4 electrons. And we know that these guys over here are the noble gases and are relatively stable. We know these guys right here are the halogens, and they're not very stable. They like to be with themselves. So you see fluorine, chlorine, bromine, all together in the same one. And this has got looks like some Latin names. Okay, so good. So let's move on. Well, we cleared it. I don't want the pen anymore. There we go. Now we go. All right. So the important ones are these basic important ones. We could add copper in here, but we might not. Just depends. It's one of those that pop up because some critters use copper instead of iron to carry oxygen. Okay, so these first guys are extremely important. So these first guys right here are extremely important because they're going to make up or organic molecules. And of course, carbon is the main one for organic molecules. Okay, so C, hydrogen, and most of our carbons, hydrocarbons, so carbon and hydrogen. We're going to see nitrogen and oxygen along with these. Okay, so these are the big important ones. Phosphorus, sulfur, magnesium, iron. We're going to see a little bit of them. We're going to see that the uh, cell membranes are made out of phospholipids, so we need to know phosphorus. We're going to see that sulfur is a byproduct of some decay, so we're going to see it. Magnesium, we're going to talk about it as far as with photosynthesis, and of course, iron makes our blood red and helps to carry oxygen. So we're going to see that. So these are just going to give you an introduction. These are the ones you can kind of commit to memory. The first 4 you really need to commit: carbon, hydrogen, nitrogen, and oxygen. So those you need to commit, and we're going to talk about them more in depth here a little later. Okay, so the rest of them you can kind of know, but we're going to talk about them again when we come up with them. Okay, all right. So the first one some things we got to talk about and get out of the way. We got to talk about molecules and covalent bonds. Your book kind of divides some things up too. I in my learning, if it's a covalent bond, it pretty much is a molecule because they share electrons. And here are just different ones that share electrons. Carbon and 2 oxygens, carbon dioxide, we're going to deal with water here in just a minute, and then talk more about water uh, in just a minute. We're ammonia. We're going to deal with not necessarily ammonia with three, but we'll deal with an ammonium with just two hydrogens attached. Of course, nitrous oxide and the oxygen molecule. So, for the most part, molecules are pretty much covalent bonds. Okay, your books kind of doesn't necessarily make that distinction, but and it's not really that super important. But when you think molecules, you should think of oxygen, carbon dioxide. You should think of water, definitely, like right off the bat. When you think of molecules, think about water. Okay, compounds are usually contains atoms, two different elements for the most part, and they're ionic. So which means they don't share, but they give it up. So we see sodium here gives up its one electron to chlorine, and again, so this becomes more negative because it's got less protons. I mean, not protons, less electrons. So they got more protons, less electrons. They got more protons in chlorine, and it becomes a little bit positive. So the idea here is that opposites attract. Okay, and that's what holds a covalent and an ionic bond together. So opposites attract. This shouldn't be anything new. You should have got it in physical science. If not, that's okay. Opposites attract. Ionic bonds, compounds. Usually a metal and a non-metal. Usually. Doesn't have to be, but not for the most part, usually a metal and a non-metal. Okay? So the questions are on your own. What's just kind of real quick go over them. It says what determines the vast majority of atoms' properties? The protons. How many protons an atom has determines what that element is. Okay, if it's 6 protons, it's carbon. If it's 12 protons, it's magnesium. Um, that determines what they are. It says an atom has 13 electrons. How many protons does it have? It's got 13 because they're equal. And again, it doesn't mean that they're not reactive. Okay, doesn't mean that they're not reactive. It just means that they're equal. Okay, 2.3, identify each as an atom, element, molecule, or compound. Okay, so for the most part, we do the easy ones first. We know that that's an element. We know that that's an element. Okay, so we know that, or an atom, kind of goes hand in hand. That's one of those things. Carbon, maybe that's what they mean about an atom right there, carbon 14. Anyway, for the most part, I think they're going to call NH3 a compound and P4 maybe a molecule. Kind of look in the back and get that. To be honest with you, this right here is, hey, biology, we're going to call it what it is. If it's a molecule, it's a molecule. If it's a compound, we're going to call it a compound. Okay? And for the most part, we're not going to have you figure it out like you had to in physical science. We're going to tell you exactly what it is and what it looks like and the chemical formula and all of that stuff. Okay? 2.4, why do isotopes of an element have same chemical properties? Because it's got the same number of protons. They differ in the number of neutrons. Okay, carbon 14, carbon 12, uranium 234, uranium 238. Those are all isotopes. And we're really only going to deal with one, and that's carbon 14. So, and even then, it's iffy what we deal with. Okay. On page 40 and 48 says a student is told to study chemical nitrogen monoxide NO and nitrogen dioxide NO2 and determine their differences. Student reports there are no differences between molecules because they're made up of the same element. Is that right or wrong? They're made up of the same elements, but in different ratios. So carbon monoxide and carbon dioxide, nitrogen dioxide, nitrogen monoxide, there we go. Nitrogen monoxide is laughing gas. Nitrogen dioxide is usually the gas we'll find in the atmosphere. So even the ratios make them different. So we got one that's a 1 to 2 and a one that's a 1 to 1. So this one right here is a 1-to-1. Looks like a smiley face, sorry. And this one, uh, it's hard to draw with this pen. 1-to-2, okay, meaning nitrogen to oxygen, okay? Um, so yeah, you're right. They can made up the same elements, but no, you're wrong. That because they're in different ratios, they're going to be different. Name each element and number of atoms in this molecule. This is acetic acid. There's 2 carbons, 4 hydrogens, and 2 oxygens. Okay, this does not mean what they look like, how they're arranged. For the most part, carbon is together. Hydrogen is attached to carbon. Okay, so this is vinegar. What's the difference between ionic and covalent bonds? You should know that. Ionic is give it away, so they become opposites attract. Covalent bonds means they share. Okay, in which most all bonds in living organisms are covalent for the most part. Okay, so that's good. We're done with that. So let's move on. All right, here we go. I think that's it for this one. Yeah, it is it. So if you got questions, you can't remember, go back. You can't remember what an ionic bond again. Opposites attract. Covalent bonds they share. Those are the big 2 things. We're going to tell you what elements you need to know. We're going to tell you this stuff in biology. Okay, so this is relatively just a basic review. If you don't if you have trouble, hang on. We're going to come back to them again and again. We're not going to expect you to draw carbon or draw hydrogen or draw nitrogen. Okay? All right. So good deal. We're going to move to water next one and then into the organic compounds in this book. So thanks for viewing. Move on to the next one.